Okay, so in Algebra 2, you learned like a bunch of different functions. And today in pre-calculus, we're going to like summarize a bunch of them in like 30 minutes. Okay? We're not going to go too in depth. We're just going to start talking about like what the function looks like and what its domain and range are. So first of all, I keep using this word function. In Algebra 2, at some point, you may have talked about when we have a graph. If it is a graph that you have a vertical line and the vertical line only passes through the graph one time at any place, then it is a function. You also may have learned that if you have a table of values, none of the x's would be repeated. Because if the x's were repeated, then this vertical line would hit more than once. Another thing you might have talked about is basically there's a y value in it, and the y value is only to the first power, and not be to any other power. So we could solve it for y equals if we wanted to. Those all kind of determine what a function is. Okay, if it is a function, we can write it in function form, which instead of saying y equals, we say f of x equals f of x. Do you know what f of x kind of stands for? It probably says it up here, but do you know f? The f of x stands for? Does anybody know? Yeah, and I just like to say it's like the function at the value x. So what is the value of the function when you plug in a given x? That's exactly what it means, and that's what we know as y. So it's just a fancier way of writing it. When we talk about the domain of a function, we're talking about which values? X. If it says f of x, then it would be the x values. So we do usually use x, so we know it as the x values. But if it was like a's and b's, then you can't really go with x values. You know, sometimes they throw you other letters. So another way that we could describe the domain would be the input values, the stuff you put in first, the input values. And then the other way visually that I'm going to talk about domain is how far it goes to the left, how far it goes to the right. Everything left to right. Domain is left to right. So using that, let's write down what the range of the function is. What's something we can say about the range of the function? The y values, I was just copying what he was saying over there. The y values, up and down. And then what else could I say about the output? It is the output. It's what you get out. So linear functions are in the form of f of x equals mx plus c. And the domain for any linear function, you could draw any linear function that you want. Drawing all the linear functions I can think of. Domain of the linear function would be how far to the left does it go, how far to the right does it go. All real numbers. So you can write, today we're going to write in set notation, all real numbers. You can also use the abbreviation, that fancy R, if you don't want to write out all real numbers. Okay. This is set notation. You may have learned interval notation, which we will do in like 2 days. Okay, but today we're going to do set notation. I know that it's really important that you've seen both notations in other courses. Does anybody think I skipped a graph up there? Is that a function? It doesn't pass the vertical line test if it's vertical, so vertical line is not a function. I was waiting for somebody to say something, but you didn't, so I had to bring it up. So I'll put a note over here, vertical line is not a function. They would not pass the vertical line test. So you can't write it as f of x equals something, because what does f of x represent? Y. And that equation is x equals, not y equals. Okay, range, down to up, auto numbers. And what intercepts, why do I ask the intercepts? Oh, well, I now remember, sorry. Intercepts, how many intercepts typically are there? Typically. It's usually 2. There could be 1. If what's the intercept? If it went through 0, 0, it would be the same for x and y. I'm just going to put the x-intercept would be like x, 0, and the y-intercept would be 0, y. We don't have really an equation here with numbers to know. And then for end behavior, or behavior of the graph, I'm not going to take the time to fill all of these out. It's on like every single question, but it's not in our homework tonight, and we're going to hit it at a different point. The behavior of the graph, I'm going to do it for this one question, but then we're going to kind of skip it because of time. But like, if the slope is positive, then f of x increases as x increases. So that's just saying that as it goes to the right, the graph goes up. And then if m is negative, f of x decreases as x increases. And we're going to like study that later in this class, so I'm not going to really focus on that right now. But it's like on most of those questions, I'm going to just keep skipping them. All right. It won't be in your assignment yet. And then this is just vocabulary. A constant function would be a function that has 0 slope. 0 slope. It's in the form like f of x equals, say we're at c, whatever, any number. Identity function, though, is where f of x is equal to x. So this would be ordered pairs like 1, 1, 2, 2, 3, 3. 137.4, comma 137.4. So that's called the identity function. It goes right straight up down the middle. Up and down the middle. Okay, you don't really have to have that exact number. All right, this one we're going to have in our assignment. I think there's 3 questions just like this one in the assignment. Let's see. Write the linear function f for which f of 1 equals 3 and f of 4 equals 0. Then graph the function. Write the domain and range of the function. So we have 2 pieces of information. F of 1 equals 3. What do you know about f of x? What do you know about f of x? What is f of x? It's the y, is that what you said? Okay. It's y. So if I know that f of x equals y, and here they've told me f of 1 equals 3, what is x when y is what? So I have an ordered pair. 1, 3. I'm going to do that again. So f of x is the same thing as y. So now my second piece of information, f of 4 equals 0. So if I'm inputting 4, I get out 0. So I have an ordered pair. Now we have to write the function, which is the equation, just in function notation. So we have to write the equation of this line. How do I write the equation of this line? What do I find? Slope. You know how to do that? Got my slope. What do I do now?
Plug it into y minus y1 equals slope times x minus x.
So y minus y1 equals m times x minus x1. And Anna, what's that formula called?
So that's slope intercept. Point slope.
Point slope, because there's a point you put in and the slope you put in, right? So which ordered pair should I use? Doesn't matter.
4, 0.
Doesn't matter.
No.
No, but 4, 0, because that one has a 0. Totally, okay. If you already used that one, because some people are working ahead, that's okay. So y minus 0 equals -1 times x minus 4. So y equals negative x plus 4. This is not the answer. It's almost the answer. But the directions say, and I'm reading over if you don't mind, write the linear function f. So this is not the linear function f. This is just like y equals. I need to write it in function notation. So how am I going to change this equation now? F of x equals negative x plus 4. That's all I had to do to fix it. So when we're writing linear functions and they tell you to call it f, that you need to write it f of x form. Oh yeah, yeah. Okay. If you don't have a straight edge, because some people forget and put them back, go ahead and grab it. Okay, and then we do have to graph it. That doesn't sound good. I'm going to graph it by plotting the two ordered pairs. I'm also going to graph it by graphing my line just to make sure I didn't make any silly mistakes. So the ordered pairs have to be right. They were given to me. 1, 3. Unless I mix them up and went backwards. I've seen people do that. 4, 0. And then I'm going to use the line, which was f of x equals negative x plus 4. I'm going to begin at 4, then I'm going to go negative 1 over 1, negative 1 over 1. It looks like I did it right. So if you get an answer and then you go and you check it using your equation, you check it using the ordered pairs given, but they're not on the same line, you'd be like, oh, I must have done something wrong. You could go back and fix that. I was pretty good without a straight edge. Okay, now let's review what's the other one. You ready? I'm gonna go fast. You ready? Here. Okay. Absolute value looks like what? What look like? Show me. Show me. Yes. Thank you for that enthusiasm. Everyone show me. Absolute value. How to remember it looks like a V. You have long arms. Thank you. How can you remember it looks like a V?
Value.
Value? Right. Like the word, absolute value. Absolute value looks like a V. And what's the definition of absolute value? I totally forgot the domain and range on the last one. What was the domain and range for any line? I realized it then. That's okay, we'll practice more with domain and range. It was all real numbers for both. All lines are all real numbers like that. All functions. Okay, back to this one. What was I saying? Oh yeah, what's the definition of absolute value? It ends up being greater than 0, but that's not the definition. You know the definition?
Distance from 0?
The distance from 0 on the number line. So I'm going to pick what I usually use as the parent function point for absolute value. Always do -2, -1, 0, 1, 2. And then we talk about how far these are from 0 on the number line. How far is -2? 2. How far is -1? How far is 0? How far is 1? And then 2. So that's why it ends up being all positive, because you're talking about distance. Okay. We graph those, and you should know from previous courses, plus we just did it, that absolute value looks like a V. So make sure when you connect it, it looks like a V. or victory, or any other word you can think that starts with a V. Value. Domain. We think how far to the left, how far to the right. All real numbers. Goes all the way left, all the way to the right. Range. You always think low to high. So how far down does it go? 0. Does it equal 0? Yeah, there's a 0, 0. How far up does it go? Infinity. So I can't say all real numbers. I'm going to basically say it's everything from 0 and above. And since it's range, I'm going to say that the y values are greater than or equal to 0. So that's how we're going to be writing our domain and range if it's not all real numbers today and like tomorrow. All right, intercepts. Are there any? 1 for each. X-axis hits at 0. Y-axis also hits at 0. So both x and y intercept at 0, 0. But this is the parent function. You guys talked about transformations last year. So from the parent function, we're going to transform it on a different day. Quadratic function. What's quadratic function look like? Looks like a U. Parabola. Let me see them. Give me quadratic. Yeah, quadratic. All right. Well, that looks so good. I needed a picture of that. Too late. For the point, there's not many of them that I use more than 5, but this one I like to use 7. So we'll just go. And I go -3 to 3. And when you plug in -3, or you plug in -2, or you plug in -1, and then you square it, what always happens? It becomes a positive number. So these will all be positive answers. And they're all perfect squares because we have no transformations. This is just perfect squares. 1, 1, 2, 4, 3, 9. And then the reflection of that. It is a U shape. It is not a V shape. So make sure at the bottom it does not come to a sharp point. Domain, left to right. All real numbers. Range, down to up. How far down? Goes to 0, then it goes up from there, so we say y greater than or equal to 0. Intercepts for both x and y at 0, 0. Did you have to memorize those points last year? Did anybody have to memorize them last year? I'll look at my previous. Were you the only one that did things? So Paige is going to get picked on a lot. She has to be right on everything. Just kidding. All right, cubic function. Yeah, well, you're doing like the Egyptian like hieroglyphic. So I'm going to face away for you for a second. So this is quadratic. That's cubic. Quadratic, cubic. Quadratic, cubic. That's it. Yeah, this one kind of stays. Well, actually, it does stretch a little bit, so I kind of totally did that perfect. But I will always face you, so I'll do it this way. But this is like you looking the correct way. The points I use points that will actually fit on the graph. So -2, -1, 0, 1, 2. And when we cube -2, when we do -2 times -2 times -2, we get -8. Yeah. I gotta find a better sound. I just keep forgetting to change that awful sound. It's better than it was, though. All right, graph again. So last year you may have talked about that this point in the middle is not called a vertex. Anybody talk about that last year? That's not a vertex. It's a vertex with quadratic and with absolute value, but when it does this, it has a different name. Does anybody know that name? Sucker, do you know that name? I have name. Oh, the one thing you don't know, Anna!
What's it start with?
P.
I can't think of it. I know what it is.
That's
Starts with-
It's called a point of inflection. Did you learn it?
Oh, that was my next best.
Oh, was it? Dang it, next time. All right, so the domain, left to right. All real numbers. It goes on forever. There's nothing that's stopping it. All real numbers. Range, down to up. All real numbers, nothing stopping it. Intercepts, they're both at 0, 0. All right, square root. You know what that looks like? Okay, so this is quadratic. This is x squared. And then the square root is the inverse of that. It undoes this, so you like turn it. Except this only says positive square root, so then I got to get rid of that one. Yeah, that's what I was saying. So if it was a square root, it was a square of quadratic, and then the inverse of it is a square root, but that's only positive. You can pick whatever x's you want, but let's be smart. I'm not going to pick -2, -1, 0, 1, 2. Why? So what happens when you put -2 into a square root? It's imaginary. You can't see it, so don't use that one. What is the smallest one that is going to show up? What? Oh, smaller. 0. We can take the square root of 0. It's just 0. Now from there, I could take the square root of like 0.1 or 0.001 and all those, but I'm going to pick ones that are easy. So I'm going to pick 1 next. What's the next square root I should? Right, I don't want to do 2. That's silly. I want to do 4, and then I'm going to do 9, and then after that, I'm off my graph. Oops. You graph those, and you'll see how it looks like your parabola from before turned on its side and only half of it. Domain, all the way to the left, all the way to the right. We have not all real numbers this time, do we? X has to be greater than or equal to 0. And then the y, we think all the way down to all the way up. The lowest it goes is 0, so y is greater than or equal to 0. Intercepts, it's still that same answer. Well, x and y at, no. All right, reciprocal function. You may have heard this as like inverse variation. What should we call them? Not sure what else they're called, but I'm just going to call it reciprocal because it says x, it's 1 over x. I'm actually going to choose 7 values instead of the 5 that we have spots for, just to make it like more obvious what the graph looks like and more symmetric, just to help you draw it better. I'm going to pick -2, -1, -1 half, 0, 1 half, 1, 2. And then when you put that into the function is 1 over x. So if I do like 1 over -2, what's my f of x? It's -1/2. Or if I do 1 over -1, it's -1. And what happens if I do 1 over -1/2? So instead of dividing by a fraction, you multiply by its reciprocal. Instead of dividing by a fraction, you multiply by its reciprocal. So the answer ends up being -2, which is why I put that fraction in there, because I knew it's going to flip. It's a reciprocal function. Flips them off. Ooh, but what happens when I put 0 in there? Okay? I can't. The world blows up. Yeah. It would be undefined. So I'll put undefined here, and then we'll put that on the graph in a moment. sort of. And then the rest of them are, what's it called, kind of symmetric with these numbers above, except for they're not negative. Okay. I graph them, -2, -1/2, -1, -1, -1/2, -2, that one, that one, that one. So those are the points that I could graph. Now that undefined, that's where, like, it will never, ever, ever equal 0, and you can kind of see where the graph is going. You may remember from last year, there's asymptotes in this one. Asymptotes? Yeah, so there's an asymptote where it's undefined. We would draw a vertical asymptote. And so the graph is going to get closer and closer and closer to those asymptotes. There's another asymptote that you didn't get from this table, but if you think about it, what can I put in for x and have y equal 0? 1 divided by what is going to equal 0? Nothing. So this can never happen. So we also have a horizontal asymptote. And then we have these two separate branches because it skips over, that point's not there, skips over where it's undefined. So the domain, all the way to the left, all the way to the right. Does it go all the way to the left, all the way to the right? Why are you saying no? It does, but not the middle. It skips over something. What does it skip over? Do you know what?
0. Well, I know the other one notation. It would be negative infinity, 0, union, 0, infinity.
Yes. Do you know what is that notation? So in set notation, it is just x does not equal 0. That's all. It's basically saying x can be every single number except for it's not 0. How about range? All the way down? All the way up? Except for 0. So y does not equal 0. Intercepts. X and y axis? None. Okay, so those are basically our parent functions. The rest of this will be more like your assignment. How much time again? Not much. The rest of this is going to be like your assignment, where you're going to graph these and answer like domain and range about them. But you'll see now it's not the parent function. So I'm going to give you the option. If you remember how to do transformations, you can do that. I totally haven't taught any transformations yet. I'm going to go over it. So if you do not remember how to do this with transformations, where you take the parent function and then what's plus 2 do? This moves it up 2. If you don't remember that, then all you have to do for your assignment is plug in numbers for x, find y, and graph them. Okay? And then write the domain and range as well. I am going to go over transformations, and if you already know them, it's going to take you less time to do that. Okay? So, pretend I don't know transformations. I would just plug in, I don't know, whatever I want. -2, -1, 0, 1, 2. I'm going to square the x, then add 2. So this one would be 4 plus 2. This one would be 1 plus 2. This would be 0 plus 2. This would be 1 plus 2. And 4 plus 2. So I would have -2 6, -1 3, 0 2. Remember, quadratic should be a U shape, and it should be symmetrical. So once you get 3 of the points, you really have the other 2. And if I'm going super fast, this video will be posted as well. Plus, there's probably a million videos out there. Domain would be left to right. How far to the left, how far to the right does parabola go? All real numbers. Range, how low does it go?
2.
And then it goes all the way up, so y is greater than or equal to, that's number 2. I'm going to do that one, I think, next, but I just wanted to check and I couldn't remember what my other ones are. We're not going to get through all of them. Let's look at the next one. How many, if you're doing transformations, how many transformations are on this one from the parent function, which is qx? How many transformations? 2. One of them is what? Up one. What's the other one? Reflect in which aspect? Because it's, we'll review it right now. We'll review it, but like, you know, if you're not sure, then just plug in points. If you're not sure, just plug in points. I'll plug in -2, -1, 0, 1, 2. If you plug in points and your points are like way off the graph, then make your chart longer and plug in more points. Okay? And if you understand transformations, totally do it, or maybe, you know, check with your graphing calculator afterwards, making sure you did it right, but don't do this with your graphing calculator. Okay. So if I plug in -2, I'm going to have 1 minus -8. I'll have 1 minus -1, 0 minus 0, no, 1 minus 0, sorry. 1 minus 1 and 1 minus 3. So -2, 9. -1 is 2, this one. I didn't connect that very well. Domain is all reals, range, all reals for that. So I will fill in those last two graphs. I think it's just 2 more, right? I'll fill in those last 2 graphs if you want to go to Canvas and pull them up, like if you want to have them, or if you worked ahead and want to check them. I'll fill those in and post it. You don't have to finish your notes, but if you want to have a complete set, I'll upload it and complete it. I just couldn't get to it in the time that we had. But I think we went far enough. You guys know what domain and range is. You know what the parent functions kind of look like. You just have to plug in points to grab them. Or use transformations if you remember. Yes, patient. Okay. One of these days, I'm going to learn how to count. Sometimes these stick together in this way. Not very well. Yes. Nope, that's not it.
One moment.